Hello friends, welcome to How to VLAN channel. This is DBA VLAN stream. Today in this video, it is out of ordinary. We've been doing some installation and setup videos, but today we're going to see something in Optimizer in Oracle, partition pruning. So I'm not going to talk in detail about how Optimizer behaves with partitioning, but this is one specific requirement I am facing in my real work, and I was troubleshooting it in my lab, and I think I found the answer. I just wanted to share it with you. So I've been going through this lab for last 3 days or so. That's why I didn't do any other videos. And I was focusing on this particular optimizer issue because I need to deliver this in my real life work. So what is this? One-off situation. Yeah, that's the reason I say it's one-off situation. It's not an exhaustive partition pruning examination or a partition pruning mechanism explanation. So, in Oracle, you have partitioning. That's, I think, it's there from 8A or 9A, I don't remember, but it's there for a long time. Data warehouse. I learned Oracle from Oracle 9A. I started my career. But then I got exposure to work in Oracle 8A as well. The only thing that I didn't touch is Oracle 7 until now in my career, but I worked in Oracle 8.107 until now, and all the versions. 8.107, 9.207, 9.205, and then 10.202, 10.201, 10.204, 5, and 11.202, 11.203, 11.204, 11.201, 11.107, 12.102, and then 12.201, then 18C, no, I didn't work, and then 19C across multiple versions. Now we are trying to install 23C and getting exposure to it. So let's talk about partitioning pruning. Let's not waste much time. So again, welcome to How to VLAN channel, and this is DB VLAN stream. All right, what are we trying to achieve today? So if you see here, our objective: does Oracle perform partitioning pruning when you don't directly provide the values for the partition column in preference field? So what do I mean by that? So you have a query which is joining two tables, and the table A is a partition table. The other table is a non-partition table. But the other table just stores some key information about what the partition table has. Partition table, normally we partition a table because it's huge in size, isn't it? A table anything more than 2 GB in size qualifies for partitioning, but that was an era when there were slow spinning devices. Nowadays you have SSD, even my size may be increased 2 GB to 4 GB or something, it's still fine. But in the era when there were spinning disks, Oracle documentation themselves, they said anything more than 2 GB, try to partition the table. Alright, so a table which is of size some quantifiable number is partition, and the other table which only stores key information is actually a non-partition table. So now we wanted this non-partition table to drive the partition table. We will provide all the values for the non-partition table, but this non-partition table has some fields which in turn will drive the partition table, and we want partition pruning to happen that way. So let's get into the example, then you will understand what I'm trying to say. So say I join the partition column with the other table. The other table is a non-partition table, which in turn supplies the partition key column values. So that's what we're going to do. Now, this is an example coming from Oracle documentation. I'll put the URL so you can look at yourself. All right. So Oracle provided, I think, for 4 partitions of year 2006, but I added more partitions. So this is exactly the sales table, which is partition table. I added for 2023 and 2024. And this is the other table. The other table which drives the partition table. So reference table, which is product. Actually, I added 2 more columns. I'll let you know why I did so. But for now, I'll mention them here. So just give me a minute. Where is that? Yeah, these 2 fields I added of late. So really, I have 4 fields in here. So this way you will know now. because while I was troubleshooting, I learned that the other method is not going to work. So I had to add this. Okay, now let's look at this reference table. Has this four fields: product ID, time introduced, sales season start is a date, sales season end is a date. So what it means is we are trying to identify um, information about selling of a particular product. All right, it can be during the peak season or it can be time since it was introduced. It can be either of them. All right, so let's go into the detail now. So I loaded the data like this, and then I find the first query I ran was actually to find out the selling of the product since the time it was introduced in the market. All right, so now this is the query: select product ID, which is product ID, quantity sold, amount sold, which is there is no relationship between these two tables, sales and product, which I will show you in the data modeler view. You see, refresh. All right, fine. If you see here, there is no relationship between these two tables. This is one complete independent table. The other table is also an independent table. I'm not sure if you can see it very fine. Now you see here, right? This is the data model of the table. All right. So I'm not putting the DDL of it here in screen, but you'll see them in the blog. So I'll upload a blog about this. So you can see here, this is the data model. There is no relationship. If there is a relationship, you will see something like this. I'll show you, for example, in the data modeler. Okay, anyway, I'll show you this at a later stage. But for now, there is no relationship between them. If there is a relationship between them, you will see a Krolak diagram indicating what is the relationship between these two tables. Now there is no relationship. We're sure. For this testing purpose, I didn't put any relationship. I'm not sure if this relationship is going to make any change. But on my situation, in my work, I don't have any relationship between the parent and the child table in terms of the parent key and the referential constraint. There is nothing like that. Now, let's go into the details. So the first query I was testing is, you see here, the sales table and the product table. They are joined on top of the product ID with only the sales table, product table getting the product ID information, which ideally means how this query will behave is how this query will finally be transformed as a dot product underscore ID also equals 20. That is what it will learn. Alright, so what I was expecting is, since there's a time field, time introduced, Oracle somehow will sense this, but it is not the case. It will not sense it unless you directly feed them the information. So what it does is it does a partition range all. So all the 8 partitions were scanned. There is no whether this query performs in a short duration or it doesn't perform in a short duration, irrespective. I want the partition pruning to happen. That's my objective. But it did all the partition scan, which is equal to a full table scan. Table access full. Okay. So, but then it was using dynamic sampling. So I decided to apply the stats as well, and it's the same. It didn't change. And the next test scenario, since that was the first test, so we wanted to see if anyway Oracle senses the relationship. There is a table here, and then there is a time field in that, and the time field can be used for optimizing the partition table, but it didn't happen. And the next one we will do is uh, we will directly supply the time values. You see here, time ID. So we will directly supply the time values on the sales table. So same query, which is product ID, but this time I'm supplying the literals of the time. And when I do that, it's just doing a partition range single. You can see here, only one partition has been scanned for this particular quarter. So this is good, nice. So partition pruning happened, but this is very complex to write in a real world. When I say I want to apply this fix for the customer, I cannot give the literals at all. It's very challenging. So because every time the query needs to be created in the application with the literals, and it is very challenging. So I will skip this solution for now. The next solution I wanted to try is using the field itself, the time that it was introduced to this field. And I ran an explain plan for this, and again it did a partition range all. And it's obvious why it would have done that is because we put a greater than symbol here. And I think if you use this wide open greater than and less than operators with no other criteria on the time, there is only one operator which is less than or greater than, I think it has no choice because it's like throwing a stone on to open sky. What do you get back? You do not know. So it will do all that full table scan only. So I think this is the reason why I didn't do this. The same dynamic sampling is to level 2, but I applied the stats and it's the same. Nothing changed. Then I decided to add these two fields. I showed you on top itself that I had additional two columns, right? That these two columns I added at a later state because I don't want this wide open field. I wanted to have two fields to mention the start and end, the begin and end. I can introduce it here as well. Time introduced plus 60 days or something like that. That is also obvious. I can do something like that, but I just wanted to be very realistic. So I wanted to change my test setup a bit. So I changed it here and I updated the fields. And then again I ran the query. This time you see here now I put a less than symbol and greater than symbol on the time field. And still it's full table scan and partition range all. You can see this dynamic sampling, but with the stats also it didn't make any change. I'll show you one of the examples, okay? In the live scenario, I have the session open, but I'll show you after running through this actual outcomes, okay? So still nothing has changed. Oh, I was wondering why. I was still doing a partition range all and then table access full because I filtered out the fields already, but it didn't still doesn't know. Or the way this optimization has worked, it might have applied the product ID first and then the time range it was looking to. So the way the access method worked was different. So yeah, you can see here the access method, it first applied the product ID. Then it applied the filters on top. So now let's see if we can make this as the access method. Alright, now the next option. So with the stats few checks, so you can see the same routine. I reran this. It has not changed. For the query product ID and time, still the same access method. And then I ran the original queries here. Time ID between. Okay, now comes the change. I wanted to try without the greater than less than symbol instead between operators. And it has not changed it. It is the same. All the partition range, all table access full. Nothing has changed. And then again, I was just running through the old examples with the stats. So this is immaterial for you and for now because nothing has changed between this with stats or without stats. I just want to be sure, so I ran this. So it did not make any change. This is the first time we saw here. This ran with a full table scan, isn't it? Now, here is where the change is happening. Alright, so here it properly sensed sales season start and end. This time it picked up the partition key. So yes, so just give me 1 minute. Okay, friends, so this repeated test scenarios, I had to overlook. If you see here, without the stats initially, it was doing a full table scan. So Yes, now I understand. Okay, fine. I'll show you. All right. So this is the key difference. Why there is a okay. See, this is the difference. See here. We are doing an explain plan for on the sales and product where we have a join on the product ID column, and then we are filtering on the other fields. So it is still doing a full table scan. I didn't have a overlook. I was correct, but I'll just show you, explain you. This is a key difference between the one with partition range iterator and without that. So here, this is what you have to pay attention to. This preference clause. So I'll show you the example difference. So full full table scan FTS. Okay. Here, look at only this preference clause. Rest all doesn't change. Okay, you see here we are joining on the prod ID column. All right, and then we are seeing the product ID filtering. So here, this is the predicate information for this particular query, and it is doing a full table scan. Okay, so here this accesses based on this. All right, so it will only access based on the product ID. It will not filter out and then applies the filter on top of it. So it's still doesn't do the partition pruning. It's doing the full table scan. Now this old examples. So I just got stunned by the old example, and again suddenly there is a partition pruning. I was quite surprised, but okay, this is the difference. So you see here. Look at this preference column where we have partition pruning. Look at this. I don't have the join on top of the prod ID at all. This is to test whether the access method changes if I don't join the product ID fields. This is completely a wrong use case. When I say wrong use case, this is completely not the business case at all. I wanted a sale of the product during its sale of a particular product during its sale time. When I say sale time, offers were there, something like that. During the sale time, how much product was sold? That is my objective. But if I run it like this, product ID will supply the product ID 20, and then the sales season will supply the sales season start and end. But it is possible that more than one product had the sales season starting and ending within this window, which means that I will get multiple product outputs. So I don't want that. This is a wrong business case. But I wanted to test how this works. So putting it in trial, you can see here there is no access at all here, and it used partition pruning. Clever, right? Now Oracle had only one join information, which is this time field. It doesn't have any other information, any other field which is joining product and sale table. Now we are on track. So now I wanted to first filter my product table, sale table by picking the time range. So I wanted to pick up only the selected list of partitions and then apply the product ID on top of it. Easy, right? You get me now? So what I'm trying to say is, say for instance, I'm going to run the wrong example. I'm going to filter or select the partition. First, I need to identify the partition which contains my sales data. I don't want the whole partition because imagine this is a very small example. I have only 360 records. In live scenario, you may have 360 million or 360 billion records. For instance, Flipkart, Amazon, they will have a lot of sales on the product. So you need to filter, okay, I only wanted to look for April month sale. So select the April partition alone. April partition alone, and then go to the particular product ID. You're good. And you can create an index on top of it, on the product ID with the local partitioned index. On index on product ID, you will be very, very quick. Okay, I'll do a separate video on that. But this is the very much ask. I wanted to first to filter. How do I do it? This is the method. I run the wrong query. I get the partition selected. Then I apply the product ID want. So the product ID field is instructing the sales table with the time range. See, this product ID 20 will give the time ID of the sales season start and end for prod ID 20, but there can be many products sold during the same window. Then next we will apply the prod ID on top of the result set. How do we do it? We have subquery option and then we have materialization option. I always use materialization. Okay, this is materialization. Okay, see what I do here. I use the same logic I used on top. You see here, but I used a bind variable in order to avoid literals being passed repeatedly for the prod ID field. So I am supplying the prod ID here. Alright. Same query on like on the top, and I am getting the sales season start and end date for this prod ID. But there could be many products sold during the time. But all we need is all the products which are sold during the sales season start and end, their product ID, quantity sold, amount sold from sales table. This is what we want. That's there now. That's there with us. Next, I run the same query. I ran the query out of this materialized view. I get what I want, which is applying the prod ID. I achieve the same. In the top, I just rewrote the query. In the top, I want to achieve what I want, right? So I can rewrite the query to let the optimizer know, because the optimizer is not able to sense this relationship, which virtually does exist, but Oracle doesn't have that intelligence to sense the two fields which has a relationship between them. It cannot happen. Ideally, you have to instruct Oracle. This is how I am instructing Oracle. You first filter my record, get the partition out, and then apply the product ID on top of the partitions you filter. Select the partitions and filter only the product ID you want the sales for. And you see, bingo, we got the answers. See, the table access is full on product, and the sales, it's a partition range I did. It can be one partition or many partition based on the sales window you get. And how do we rewrite the query? Again, and this is a simplistic query anyone will think about. You will put a inline subquery. But there are problems with this inline subquery. You need to use view, unnest, unnest, and so on. I normally don't prefer this, but it's easy compared to this materialization. So, and still it reproduces the same results for me. But when this with these inline views, Oracle has this optimizer intelligence which comes into play. It will merge these two views together and it will come up with a new plan. When this two gets merged, it may become like this. The original plan where we had partition full scan happening, right? It may become like this. Not like this, not this, like this. So Oracle may merge it to frame a query like this. It will rewrite the query on its own with inline views, which I inline subquery, which I hate. So normally I don't prefer that. With this identification, it is not possible because you're identifying the view already with some names. Still, I think it is maybe possible or not. I don't know. I'm not so much into the optimizer, but this is a solution that I'm going to offer. But the real work that I'm working on, real life scenario I'm working on is 100 lines or 200 lines of query where they had a union of two outcomes together, and in every union, I mean, in the every row source, union of two row sources, and in every row source they have this partition pruning, and then the access issue. So I wanted to fix that, and this is the solution for them. Alright, I hope you enjoyed it. I'll really show you an example. I'll show you us in the notepad. Now I'll show you the real execution. Only the key difference we saw, right? That alone I'll show you. The first one we saw was the full table scan, isn't it? So this is the actual business requirement. Alright, so this is the actual requirement. You see here, what you get is a full table scan, and you get the actual requirement where you're applying the product ID filter and as well as the time range filter. But what are we looking to get? We don't want the partition full table scan because it's going to cost me a lot in case of I have millions of records. The other example where it's a wrong query. I didn't supply any filter. You see here, I didn't join the sales table and product on the prod ID field, which is wrong. Which is wrong because I love many products sold during the window. It's a wrong example, but still partition pruning is achieved. So now what this table will get me is all the partitions which fell on the particular time window we are interested in, and then we have to select the prod ID field. Okay, so now let's try the other solutions. I'm not going to supply any variable. I'm just going to supply the bind variable instruction alone. So you see here, there's a two part to it. First part, with TS, you have the same query you ran on top, which is a wrong example where you're filtering only the time range you want. In the second one, query on top of it, we're filtering the product ID. We needed to separate the filters. So the first filter will be used for the access, second filter will be used for restricting the row set. So now if I run this, we'll see. You see here, there is a partition range scan. And then there is an inline view as well. So we can retrieve the results for this as well. It doesn't make a lot of difference, but I can actually merge this inline view. And you will see the results will be astonishing. Maybe. So, and I didn't try it though. See, there is no instruction saying I'm using optimize the dynamic sampling because I have stats. So, and you can actually increase the dynamic sampling to enforce dynamic sampling to be used. So, but I didn't use it. So, but you see here, I'm still having a proper product sale table. And now the there is no, it doesn't say about the access method. It just says about the filter which is applied. So filter is on the sales start and end, and then prod ID number in the fourth table, which is sales table. And the filter B and the second row is the filter is only on the prod ID. So versus here, the original example where I had all the information put together in the same query, it takes only few minutes, say for instance few minutes to few hours in like in my case for the developer to rewrite this query, but it takes a tremendous change in the application performance. So every time manager or someone is trying to pull a report on the sales data, they will face few minutes to several hours of delay in the reporting query. But for the developer, the same one-time action of rewriting the query is going to yield a lot of benefit. Alright, and you see here it has an access method here. So this is the one which determines the access method between the sales and product table, and then you see there are separate filters. So first you can see here, see the filter on second table is the prod ID, filter on fourth table, this is the problem. There is no filter on the time range on the fourth field. It has only 20. After joining the results on the join, they're applying the filter and the access method. In our case now, we have the filters directly applied. We have the filters directly applied on the fourth field. You see, the filter is there on the fourth field now. That's why we have partition pruning coming into place. This is the key difference I wanted to call out. I hope you enjoyed this video, and I'll see if I can create more videos on the optimizer as well in future. If I find several issues, I'll definitely will do. And thanks for joining with me today. I hope you really enjoyed this. If you like, give me a thumbs up, and please feel free to share your valuable feedbacks on the comment section. Also, if you wanted to make a specific video on Oracle or any Postgres, you please make it in the comment as well. I'll make it. Thank you.